Hello, guys. Welcome to our October Lunch and Learn lecture. For me, it's a pleasure to be hosting this event this month. My name is Joseph, and I will be your host for today's Lunch and Learn. Here at Just City, we always like to share our expertise, and as part of our culture, we highly appreciate that. Today we're going to have an let's say amazing lecture given by Kevin. Kevin is a software engineer from Honduras, and he will share a topic that he thrives for. He is going to talk with us about Redux-Thunk and Redux-Saga. So these are like two approaches to getting things done, but they have like their cons and their pros. So we are going to talk a little bit about that. And if you like the topic, please stay to the end because we're going to have a live demo that Kevin will be sharing with us, and we'll also have a question and answer section at the end of the stream. Uh, Here you are, Kevin. It's all yours. Please, you can join and talk about this topic.
Hi, thank you, Joseph, for your introduction. So, as Joseph mentioned, I will talk about what Redux-Thunk and Redux-Saga is. So, and let's jump right. So, first, Redux-Thunk and Redux-Saga are both part of what we will call the Redux life cycle. In this case, Redux is as a simple definition, is a centralized state manager which by itself does not allow side effect behavior. So Redux allows us to manage our state in our application along the life cycle of the application in the front end side. And we can see here the life cycle of Redux. So first we have the UI, which triggers an action in this case. And the action is go pass through a reducer and it gets stored, right? Then the store is passed again to the UI in order to re-render the new state of our application. So Redux by itself does not allow side effect behaviors. So we cannot perform fetching an API or some sort of any other asynchronous behavior in our application using only Redux by itself. But it comes with some, we will call it middlewares here. And the middleware basically allows us to handle this side effect in Redux. So a middleware we are going to introduce in the middle of the life cycle of Redux in order to accomplish this behavior we wanna tackle down. So we have two common Redux middleware in this case, which is Redux-Thunk and Saga. The most popular options out there. So Thunk was one of the first middlewares that came to the to the marketplace in order to use. So it's really popular. And Saga, it's most new. It's a newly not newly, but it came after Thunk. So it came with a lot of other benefits of using Saga in this case. So we're gonna use whether of those of Thunk or Saga in order to accomplish this behavior. So the middleware will get inserted in the middle of the process right here, as we can see. As I mentioned before, we got the view, and then it triggers an event, which we'll call it an action in this case. And the action, before going to be processed by the reducer, is going to be taken by the middleware. The middleware will process the async behavior in our application, wait for the asynchronous process to get done, and then dispatch another action in order to get passed to our reducer and process there to be stored in our application management. So that's what's going to allow us to make with Thunk and Saga. And here we got some of the options with the benefits we are going to point it out. Like Redux-Thunk allows us to make to perform complex sync logic and simple async logic. And the Redux Saga allows us to process complex async logic, and also separate the logic in different threads, in background threads, so we are not going to interfere with the main thread of our application, and also listen to a dispatch actions as well. So we're going to be listening to different actions being dispatched and then process that in a different thread. So that's the approach that we're going to take with Saga. And also we're going to use function generators, which is a different approach that the Redux Saga allows us to accomplish these benefits. So let's move on. First, let's gonna talk about Thunk. So let's see a Thunk here in action. What is Thunk? Well, Thunk is built on the approach to have a callback functions to delay the actual execution of the dispatch action in this case. So it's a really common pattern used in the marketplace, and along all the JavaScript developers, they're all used to work with callback functions from the past times. So they're really straightforward to get into Redux-Thunk if they want to. And as you can see, the approach here is really simple. This is a thunk. We declare a function as a thunk, and the function inside the function we return the callback function. And the callback function will receive a dispatch and a get state prop in order to allows us to perform the complex async or sync logic in this case. So here a simple example of the wrapper of the thunk. So we got the dispatch, the get state, and here the code we are going to execute the complex scene in async logic, and then we manually have to dispatch the action. So we get the dispatcher here, and we pass the action when it's dispatched. And an action by itself is a simple JavaScript plain object, so a JSON object, a simple JSON object. So it's not that difficult to understand in this case. An action is a JSON object, right? So we call here in the right side, you can see we call the dispatch, which is the a function that Redux allows us to call. So the dispatch, in this case, we call the thunk, but the thunk return a callback in this case. So what's happening here, right? Redux by itself does not recognize a callback function as an action, but this callback function is taken by the middleware, in this case thunk, and it's processed by the middleware. So later on, we call directly the right action we're gonna dispatch to be processed by the reducer. So this allows us to make that approach. And you can see it's a more complex way to do that, because we gotta refactor our code. If we were only working with Redux in the beginning, we gotta refactor our code in order to handle these callback functions. But it is straightforward for the developers to jump into Redux-Thunk because they are used to this pattern. So now let's see what's a Saga, right? A Saga, it's a little bit different because a Saga is built on top of function generators. So a function generator, I'm not gonna dive that deep into what a function generator is. You can check it out in the documentation of the JavaScript documentation. But you can identify a function generator by the asterisk after the function keyword right here, right? So here we got two Saga definitions. One is the main Saga, because all our Sagas, or as the same as the reducer, we gotta have an entry point. So we call the main Saga, and inside the main Saga, we are going to call all the different Sagas we are gonna have or handle through our application lifecycle. So here's the Saga definition, you can see. And what's the difference here? Okay, the difference is that Saga comes with, let's call it effects. It's the name that Saga defines as. An effect is basically some helpers that allows us to write out our Saga code here. We can execute our complex sync or async logic in our Sagas. And every time we yield an effect, this effect is going to be returned, and the return value of this function generator is going to be processed by the middleware, in this case by Saga, behind the scenes. So if we call this function directly, we are going to receive an object as a result. So we can easily test as well, because it's going to be a JavaScript object. plain object. So and we got here the simple actions definition as well, the get users, and this is some called effects, which is called take every. So it's gonna be listening for each time this action is dispatched. The get user actions is dispatched, and for each time this action is dispatched, we're gonna call the Saga handler for users. At the right side, we can see the dispatch action in place. So we dispatch the action, the get users action, which is a plain JavaScript object, and will be this Saga will be listening for this action being dispatched all the time through the lifecycle application. All right, so all this sounds really good, right? But what about some pros and cons between the two different middlewares? Well, for Redux-Thunk, there's a small learning curve since the common JavaScript callback behavior is already in the mind of the JavaScript developers. They are used to it. And also comes out of the box with Redux Toolkit. So as soon as you create your React application using Redux or you're using Redux Toolkit, it comes out of the box using Redux Toolkit. So you don't have to install or set up all your environment in order to work with Redux-Thunk because it's already there. And with Redux-Saga, well, Redux-Saga, as I mentioned before, is thread execution. So you can have several threads in your application that will be handling each individual behavior for the different actions that are going to be dispatched in your application. And also we have a better handling of complex async logic because we don't jump into the hell of callbacks as all the JavaScript developers that are used to the callbacks pattern are also falling into this callback hell called. And also the reason that we use effects and the function generators allows us to have the easier testing. And another great benefit of using Saga is that it can be started, paused, continued, stopped, and all of these handled in the main thread with a simple Redux action. Okay, and what a Redux action is, we mentioned a Redux action is a simple JavaScript plain object that is dispatched in a Redux state management. So all of these sagas we have running in separate threads can be started, paused, continued, and stopped from the main thread of their application just by triggering a new action. So let's call that way. All right. So who's using this Thunk already? Who's using Thunk? Well, as I mentioned before, Thunk was one of the pioneers of the Redux middleware libraries in place. So it's being used for well-known companies like Instagram, Slack, and Robinhood. So and also they continue using that because once you choose between one another, it's kind of difficult to migrate and it takes time and also money from all the migration process from one to another. And if that's already working, so let's continue using that way. But as we mentioned before, the benefits and the pros and cons from different usages. So they continue using that because of that. They started with that middleware. So let's continue with that. All right. And who's using Saga already? Well, Saga is also being used from one of the well-known business companies like Amazon. So as we know, Amazon handles a lot of different actions in place. So they have different threads running in the front-end application in order to be triggered when one of the actions is dispatched. So they use Saga. And also another, probably not well-known companies, but really interesting one. So as we have sample.co, which is a sharing knowledge network to be used by businesses, and also Possible, which is a crowdfunding platform to be spread across the world. So those companies, we know they are really stable and they're using Saga in this case. All right. So let's add also a bonus. We got in Saga some advanced Saga effects, as we mentioned before. We We already knew some of the effects, like take or take every and put in the previous example. So here we got another advanced Saga effects that allows us to make really interesting things, like the throttling, the bouncing, racing, block and non-blocking calls, and the flow description. So we're gonna check it out the throttling later, but for now, just take a look at what a flow description is, or an easy flow description. In this case, we got a simple example here in our application. We got um, business flow logic description, so we can describe in an easy way. For like example, this way with the login flow. We can see we got a Saga definition here with because it's an asterisk. So we wrap that into a while true loop cycle. And in this case, we yield an effect, a take effect, which is going to be listening for the login action to be dispatched, perform the logic, and then it will be waiting. The yield take is going to be waiting or listening to the logout actions to be dispatched later. So unless a logout action is dispatched, we are not going to be listening to a login action again, because this loop is going to be repeating all the time of the life cycle of our application. So we will be waiting for a login and then for a logout. And after a logout action is dispatched, it's going to be listening for a login action again in order to process the login action, right? So this way we can describe the flows of our application and use also all the conditional statements like if, for, while, or any other conditional statement, switch in this case, to describe the life cycle or the flow of our application. Cool. All right, so now let's gonna talk about a real case scenario. We're gonna emulate this scenario where we have an application that allows us to choose several files, upload it, and we're gonna see in real time how the files are uploaded to the server, and how the counter is updated, and how the text is changing color as well. So we're gonna see how we are gonna take this approach in order to perform this behavior. We're gonna use Saga for this example and use the benefit of Saga that allows us to create different threads for each of the sagas. So in the practical example, we are gonna upload the files, and for each file we selected, we are gonna create a different thread, upload the file in this individual thread, and this thread will be in charge of updating the state after it finishes successfully, or it was some failure. So it will be also updating the state to an error, but it will be in charge of each individual thread. So we'll be uploading each individual file separately, right? And let's see how simple it is using Saga. Right. So we're gonna see first here the example in place. This is our example. You can see here we have the upload and the choose file. This is using Saga, right? But first we're gonna make a small comparison between the difference with Saga and with Redux. So here we got the storage. As you can see here, I got the Saga middleware applied to the store. So I'll comment this out in order to use Thunk. So now we're gonna see just the Thunk code in place here. We are listening for all these actions triggering here for increase, decrease, add the amount here, and an async amount. So we can see here, it takes time to add it. And also with some complex sync logic here as well. All right. So we're gonna check it out in place. We are gonna see here for the async, which is the one we are interested in. We are using here the Redux toolkit functions that allows us to create the async behavior. And here, as I mentioned before, we return a function. This is the function that is gonna be um, that this is the function that is going to be returning the thunk, right? So the callback function. So this callback function will receive the amount here. We call the fetch or the async logic and return the data. So this way, with this function create async thunk allows us to create our thunk out of the box using Redux Toolkit, as I mentioned before. And we apply this in the extra reducers here with the pending and the fulfill state. So we update the state for idle here or loading, and we increase the value once we receive the payload here in our action. All right. So I'm gonna see also here the example for some sync complex logic we got here. As I mentioned before, this is a thunk, and a thunk that receives returns the function here, the callback function that receives the dispatcher, the get state, and we call here the dispatch directly, as I mentioned before. These functions return plain JavaScript objects, as I mentioned before. It's not different. It's a plain JavaScript object with a type property and payload property. So here we perform our sync logic, and then this is increased, right? So the comparison here between the Thunk and Saga, we're gonna see our Saga in place. Here we can see the Saga for the async logic, right? The Saga for the async logic is basically using the create action function. This is an action generator that returns a simple JavaScript object, and this increase the this wait for this action to be dispatched, as we can see here. We're gonna check this example later. So take every action that is dispatched for this increase async count, and for each of these action dispatch, we're gonna call this Saga right here, which is the one I declared up there. And we here perform the async logic. In this case, it's a little bit different than we're usual to. Instead of directly calling the fetcher here, we wrap that into a call effect. So a call effect will wrap that code and return a plain object in order to Saga perform the fetch for us, and then we will receive the fetch here, the fetch response here. But we are not calling the fetch directly. That's what allows us to easily easily write tests for each of our Sagas, because we are wrapping this code, so we don't have to make any mock for the fetcher. We don't have to mock the dispatcher either. So that allows us to write simple tests. So here we got the put action, the put effect that allows us to dispatch an action. In this case, the put is as a dispatcher. So we call put, and Saga understand that we are aiming to dispatch this action increment by amount. So we pass the action here, which is a plain JavaScript object, as I mentioned before. And Saga already knows what it has to do with that with this effect. So here we have another definition for the increment if odd. We can see here the definition for it. It receives the action here. So we pass the action through the parameter, and also get the current value. So instead of calling get state, we call it through a wrapper as well. So this wrapper is the select effect, and the select effect allows us to read the store of our application through the selectors. So we read the current state, and then we perform the sync logic in order to again call the dispatch the action as we made before here. Here you can see we are manually dispatching the action, and the Saga, we are wrapping this through the put effect. So the put effect is going to wrap the code or the actions to dispatch this to be dispatched in order to Saga performing this action. And here we got another complex logic used by Saga. You can see here We got the main saga. The main saga, as I mentioned before, is the entry point of our application. So the entry point we call all the sagas, and there are a bit more effects. You can see here the fork effect. The fork effect basically allows us to um, create a separate thread in order to call this saga, right? So this saga I call here in the fork effect is gonna be running in a separate thread, the same as this one here. So I fork this saga, and this saga here is defined. You can see is wrapping a while through, and this doesn't break the life cycle of our application because this is running in a separate thread. So all the time, this saga will be listening to this action, be dispatched, and then after that, we'll perform the kind of complex logic here, reading the current value, dividing the current value by half, and then incrementing the amount. You can see here we are putting the action in the store. And we got here also the upload file saga, the one we are gonna check it out in a while. But before that, we're gonna check these effects here. As I mentioned before, that take every effect is gonna be listening for each action that is dispatched in the application and gonna be performing that one. So let's see that in action here. You remember here in the add async, right? As long as I click the add async function quickly, it will be increasing all the time because with Thunk, currently we are using Thunk here, it will be handling all the action dispatched, right? So if we wanna try to reduce the amount of actions for the velocity of the clicks I put in, or if the same action is dispatched multiple times at the same time, so we can only take one of them, the latest that we see here, or we can also throttle. So we're gonna see now Saga in place. I'm comment this again. You can see here I'm passing the Saga, the main Saga, and let's check it out how it works now. All right, we got the add async again currently because I am using to take every effect. This is taking effect for all the clicks I put in the application. But if I use throttle, you can see if I use throttle here, it's gonna be different here. As long as I click on the bottom, you can see not all the clicks is taken in place because I'm throttling by 4 seconds here. So even though I'm quickly click the bottom, this is not taking place in the effect here. So this kind of complex logic, it will be kind of a bit different implementing this using Redux-Thunk, and probably more complicated. And Saga already provide us with an advanced effect for doing this action right here. So cool. Now let's jump into the upload files. We're gonna see the upload files here. Let's see how it works to get an idea. Or so you can see I got this. This remains in the local state of the component at the moment until I click the button upload. So when I click the button upload, you will see here some console logs. Let's check it out. You can see each of the console logs there, right? So the first console log, we're gonna see when it happens. Here we got the upload file saga, and we got 2 saga definitions here. One for the upload files when we get all the files, and one with the upload file for each individual file. So first, this is the one I am calling in the main thread of the sagas right here. And here I'm consoling log the files, all the files. So as you can see, this saga is in a while through, waiting all the time for this action to be dispatched. This action is dispatched At the moment, when I click the upload button right here, when I click the upload button, you can see here, I dispatch the upload files action, and this is a simple JavaScript object, as I mentioned before, right? This function returns a simple JavaScript object, and this JavaScript object comes with a payload, which in this case is the file, and we get the files here. If it's as you can see here, I get a condition if there's no files, so I will continue the cycle, or return to the beginning of the cycle and listen again for the actions to be dispatched. But if it comes with some files here, I go to process all the files. You can see I put in the storage this action to set the default, or the beginning of the state of our application. So in order to start loading our files, and for each individual file, I go through a for loop here and fork a Saga effect in order to create the different threads for each individual file. And for each individual file, I create a different thread with this action for the file where I pass the file as a payload, and call this Saga up there, this one. And this Saga here receives the action as a parameter here, which is the console log you are looking later on in the console for each file. And I try to upload the file here to an actual API call. I'm calling here an API, a free API to upload the file. And I wrap that in the call effect. So I'm not performing the fetch directly. So I'm not calling the API directly here. I could, of course I could, but I'm not doing that because I will let that to Saga. I could also do, for example, this right here, and wait, right, because it's enabling up here. But I'm not doing this because I will let that to Saga. If I do this, I will have to mock this function in order to write some tests for it, but I don't want to, right? Because it will be more difficult to write tests for this Saga if I directly call the fetcher function. So instead of doing that, what I do is use the call effect to wrap this call to the API and pass the payload and the function I'm using to perform the fetch. And then after this finishes, I update the state of my application for this file. So I get the file here in the payload, and I get the payload name, the file name here, and I set the process file. This set process file is a simple Redux. You can see right here, set process file is a simple reducer here, where I update the state and the counter of each individual file that has been processed. So as you can see, this simple way I can write a Saga in order to perform a kind of complex action, or in order to split in different threads the upload process of each individual file. And then also you can see here the test. So the test here, as I mentioned before, since these functions are function generators, I can call those functions directly. I don't have to make any mock of the fetcher, either of the dispatcher, because when I call the function .next, I get the JavaScript plain object, so I can compare directly, and I can also use the Saga effects in the tests in order to make sure that I'm getting the right state for each call of the function generator. So I start comparing each call of the function generator with the generator.next for each step, where you can see here in the first step I should receive a call effect JavaScript plain object here, which is this one I'm returning in the yield. So I can compare all of the different yields. So I compare the function generator for each yield For each GL keyword, I'm calling here, right? Because each of these GL is basically one return of the function. Unless until there's no more GL keywords, the function will be finishing with the value as a done right here, with the done as a true. And the value, of course, there will be no value because it's the last call, right? So I call the function each time for each iteration, and I compare the state of each individual call since it's a function generator, the way it works. So basically, that's the way how Saga and Thunk work differently. And as I mentioned before, for this example here in the counter, I got this condition if I'm using Thunk or Saga. In this case, for increment async, this function returns a callback function. But this one returns a simple JavaScript object. So I can write directly the JavaScript object here, for example, if I want to, and it will work exactly the same. So let's try it out. This is the increment async count, right? Let's see the increment async count here. This is the action name I assigned to this action. So instead of calling through this action generator, I will write the JavaScript plain object directly here. This receives a type, which is the action type, and the payload, which is the increment value, right? So let's check it out. You can see it's still working at async, right? You can see there. And since I got the throttle here, this is not taking place all the clicks I perform. Let's check it now. You can see there, right? And as I mentioned, this here, simple JavaScript object, right? A plain JavaScript object. Otherwise, like this, I cannot rewrite this as a JavaScript plain object because this is using Thunk and returns a callback function. So it's totally different, okay? I cannot do that with Thunk. So that's the benefits of Saga as well, that you can have a standard of your code that using JavaScript plain objects along through your application. And there will be no issue once you start moving from not using any middleware at all and start using Redux-Saga. There will not different there will be no difference of that action dispatch in your application since there are also JavaScript plain objects here. So there will be no problem at all. And otherwise, if I use, for example, Thunk here, as we mentioned before, this is the function we are returning. So if I try to test this function, I'll have to make to mock the dispatcher, right? To mock the get state, and also if I try to mock this one, if I try to test this function, I'll have to mock the fetch count, which for Saga it was not the case, right? Because for Saga we compare JavaScript plain objects on each other since we are using the Saga effects. So that's basically the example of this this launch and learn. So we see how we accomplish this scenario using Saga in an easy way, and also a simplest way that we are splitting the code, testing the code in all the Saga pieces in an understandable way for other developers to read. So Saga comes with a lot of benefits. So you can see what is my stand when I'm using Redux and any Redux middleware. So I'll go for Saga. And yep, that's basically how it works. And this is the resources I use for building the example. You can check out the example as well if you like to. I will update the code in a GitHub repository, so you can check out the rest of the code and get used to it. And here that I really recommend the Redux Saga documentation. It's really good to jump in Redux Saga. And here comes a lot of other things like Redux tool, the official React Redux documentation, and the file IO for developers, the one I use for uploading the files. So yep, that's it. And thanks for your attention.
Okay. Thank you, Kevin. So it's been a really like really useful information about the differences between Redux-Thunk and Redux-Saga. So right now, if anyone in the chat has any question, feel free to do it right now. But in the meantime, I would like to ask you a question, Kevin, about Redux-Thunk and Redux-Saga.
Sure.
So basically, they are different approaches, right?
Right.
So which one of them between Redux-Thunk and Redux-Saga do you think it's like more propense to bugs? Like which one do you think it's highly probable to get bugs?
I would say that Redux Tongue is really propense to get bugs since you use the callback pattern that comes with a lot of callback hell calling a callback inside of another callback and a lot of nested callbacks in your JavaScript application. It really um, can drive a lot of bugs in your application if you are not that picky to get the code right. So
Yeah.
yeah, it tends to, instead of Saga where you can in a single indentation, not too many nested code, you can have your async code perform using async await function, other stuff, and also um, allows you to easily write better tests for your Saga code. Is also guarded behind um, that test. So I can also run. You can see here I'll run the test actually, and you will see that here I'm running the test for the Saga application. All the tests passed. So if I go to the test here and instead of expecting for this action, I compare to an empty object, I will get an error here. You can see one test failed, and you will see the expected return value from the function generator here. So this is the object that Saga understands, and based on this object, Saga knows what the actions need to be performed. If it's an actions to store the value in the store manager, or it's an action to call an external API, or if it's an action to read from the storage, or any other action.
Okay, awesome. Yeah, I was thinking something similar. But what about Saga? Since you're able to use like different threads, wouldn't it be like somehow propense to get lost if you have too many threads, for example?
Uh, yeah, probably you might get lost on that, but that also allows you that, or gives you the benefit that if some of your Saga throws an error in a thread, it will not be propagated through your application. It will not break the user experience, and at that point, either way, you'll have to handle the errors in order to go back to the state that the user expects to be when an error happens in one of the sagas. But it, it also leads to a lot of more um, management side from the developer in order to be aware of the different threads and how they interact with each other, triggering actions and or dispatching actions. But it also gives you more benefits than anything.
Awesome. So here we have a question from Jamil Hernandez. He asks, what pathway do you recommend to learn Redux?
What pathway? I will recommend Redux or one of the
He only
middlewares.
says Redux in general.
Okay. Well, for Redux, I would recommend to use the official documentation. It's really good. So I went through the official documentation of Redux. So you can go there. Here, React Redux or the official documentation for Redux. I also recommend you to read the paper. It helps a lot to understand um, the basis on what is the foundation of the library we're using. So Redux and Redux-Saga, they both comes with a paper, so you can go there read the paper as well.
Awesome. 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 Thank you, Kevin. Thanks a lot for your presentation, for your lecture. It was a really interesting topic. I hope that you guys like it. So that will be it for today's Lunch and Learn. Thanks a lot, everyone, for joining us. We'll be coming back soon with more events, with more lectures on our Lunch and Learn uh, lectures in the future. So thanks a lot. Thank you, Kevin. Thank you, guys, and
Thank you,
we'll see
Joseph.
you. Bye bye.